the Tyrannosaur doesn't obey any set patterns or park schedules. It's the essence of chaos.
I'm still not clear on chaos.
It simply deals with predictability in complex systems. The shorthand is the butterfly effect. A butterfly can flap its wings in Peking, and in Central Park you get rain instead of sunshine.
Why?
And did I go too fast? I go too fast. I did a flyby. No, give me that big glass of water. We're going to conduct an experiment. It should be still. The car's bouncing up and down, but that's okay. It's just an example. Now, put your hand flat, like a hieroglyphic. Then. Now, let's say a drop of water falls in your hand. Which way is the drop going to roll off? Of which finger, or over the thumb, or the other side?
Thumb. Let's say.
Okay.
Right.
Okay, now freeze your hand, freeze your hand. Don't move. I'm going to do the same thing, start with the same place again.
Right.
Which way is it going to roll off?
Let's say back. Same way.
Same way? Same back? Same way? It changed. Why? Because tiny variations, the orientation of the hairs on your hands.
Hey, Ellen, look at this.
The amount of blood distending your vessels, imperfections in the skin.
Imperfections in the skin?
Microscopic, and never repeat and vastly affect the outcome. That's what.
Unpredictability.
Right? There. Look at this. See? I'm right again. Nobody could have predicted that Dr. Grant would suddenly jump out of a moving vehicle.
Alan?
There's another example. See, here I'm now by myself, talking to myself. That's chaos theory.
So, as Ian Malcolm mentioned, one of the main aspects of chaos theory is the butterfly effect. The theory name is referring to the idea that a butterfly's wings may create tiny changes in the atmosphere that may ultimately alter the path or event of a major weather front, such as a rainstorm. The butterfly does not power or directly create the rainstorm, but the idea is that this tiny change, the flapping of the butterfly's wings, can partially cause the rain in the sense that the flap of the wings is a part of the initial conditions. That is chaos theory in all totality, that small changes in the initial conditions lead to drastic changes in the result. This inspires the overall point of chaos theory in that it would be almost impossible to track every change in the initial conditions, such as the flap of a butterfly's wings, so therefore it is impossible to know all the initial conditions of a complex system in sufficient detail, so the results are unpredictable. As in the video we watched in class on Einstein's theory of relativity, it is theorized that massive objects cause a distortion in space-time, causing any less massive objects in the same vicinity to gravitate toward the more massive object. Now, look at how difficult it is for the less massive ball to successfully orbit around the less massive ball. It is taking the experimenter many tries to even get the demonstration to work a little bit. His experiment and scenario is also extremely controlled and small-scaled in a relatively contained environment. Now picture the same scenario in the actuality of space. There are so many billion variables in space that cannot possibly all be accounted for. If the tiniest flap of a butterfly's wings can cause a dramatic weather change on Earth, then imagine the effect of a comet or asteroid headed toward the solar system and Earth. The smallest change in the conditions of all of space could dramatically alter any condition we currently have. So basically, in astrophysics, chaos commands the outcome of anything. Because chaos can be defined as any conditions in the initial system, it dictates all specifications and conditions of the resulting system or the present.